Good day. This is Mr. Stolle from Emulsion Private Tutors. So today we're going to look at financial maths, exercise 1 from my injection series, grade 10. Okay. So for simple interest, we know that it's going to be A equal to P, A representing our accumulated amount. Your P is your principal amount, the money borrowed or invested in the beginning. Then also we've got I, which is the interest, then N. Now, I want to look at it and see different types of what we call question that we can have. Okay, so the first one here from the exercise 1, we have got the first question, which we are required to calculate A, which is accumulated amount. Okay, now so looking at A, let's see what we're going to have now. We have got let's read. Trevor invest an amount of 20,000 in a bank. Calculate using appropriate formula the accumulated amount after 6 years and the total interest rate, the interest you will receive if the interest rate is 4%, so 4.5% per annum, simple interest, then also 4.5 per annum compound interest. Okay, now so we must know that we have got two different formulas. We have got the one for simple interest and the one for compound interest. Okay, let's look at number 1. So solution for number 1, we're going to use our formula. A is equals to P1 plus IN. But now, what is our P? P is our principal amount, the amount that was invested. So here is the amount that was invested. Sorry about that. Here is the amount that was invested. So it's what? 20. So it's 20,000. Okay. Then we have our I. What is our interest? Our interest is 4.5. So we say percent is 4.5 over 100. Okay. Now, what else do we have there? We have got the N that is there. N is equal to number of years. In this case, is 6. Now, we're going to substitute the values there in our formula. It's going to be P is 20,000. In bracket 1 plus, what is our I? It's 4.5 over 100 times, what is our N? Times 6. Then we calculate, we get our answer. Let's see what we get there. This is the calculator that you'll be using, the Casio. So it's 20,000. Okay, then we open the bracket, 1 plus. You must punch as you see on the calculator, okay? We must punch as we see on the calculator. Then we have times 6. What do we get? We get 25,500. So we've got, that's an amount, 25,400. Just to confirm, that's our amount. Okay. Now, what about the interest that was earned? So interest is going to be equals to 5,400 minus the principal amount, which is 20,000. What do we get? Okay, what do we get there? So if we say minus 20,000, we get 5,400. So this is our principal for the first one. Okay, now our interest. Then here is our accumulated amount that we want. Then let's look at the second question, is number 2. Number 2 is we are using compound interest here. So compound formula is P here 1 plus our I, our interest, the power of N. So the N is the power. Now, then we are going to substitute the values. You are going to use the same values that were given here because the same value that were given. So you must stick to that. So let's stick to this for both of them. Okay. Now let's have 20,000 here. In bracket 1 plus our I 4.5 over 100 in bracket to the power of 6. So here we punch in our calculator. Let's see what we get. 20,000. We open the bracket 1 plus 4.5 over 100. We close the bracket to the power of 6. Then see what we get there. We are getting is 26,050. 26,050 and 45, sorry, and 45. So we are having 45 here, comma 2. In this case, we're getting 20. Okay. Now, what is our interest? Our interest, we subtract our interest is equals to A, which is accrued amount minus P. Okay. Then we are going to say what? We are going to say 26,045, comma 20, minus 20,000. This will give us 6,045. So if you round it off to the nearest thousand, you're gonna have what is it to the nearest whole number? You're going to have 6,045 rand. Okay. So here, when you're dealing with finance, don't forget to put the what is it? The unit. Okay. Now let's look at this question here. Refilwe wants to purchase a stove costing 12,000. She wants to pay back this amount with interest in 2 years. In 2 years' time, the interest rate is 24% per annum, simple interest. Calculate the amount that she will pay. She will repay in 2 years. So we're going to use formula A is equals to P for simple interest, 1 plus IN. Okay. Now, for number 1, then if she wants to pay the loan off in monthly payments over 2 years, 2-year period, what will your monthly payments be? So here, number 2, the hint there, you are going to say the accumulated amount that you find, you divide it by how many months do we have? So months here, months, we are going to say is 2 years, so it's going to be 2 times 12, which will get 24 months. Okay. So here you're going to say the amount that you get, you divide by 24, then you get your answer. Okay. Now let's go on to the next question. In this case now, it's saying Trevor invested 500,000 in the share market. He managed to secure an average compound interest of 14% per annum during the first 2 years. Calculate the value of this investment at the end of the 2 years. So here we are told that it's compound. So it's compound interest. So we're going to say what? We're going to say A is going to be equals to P, 1 plus I to the power of N. What is our P there? We are having our P as what? Is 500,000. Okay. Then we are having our I as 14 over 100. Then we are having our N for the first one is 2. So we're going to substitute that 500,000. 1 plus what is our I? 14 over 100 to the power of 2. Then what do we get? We punch it in our calculator. 500,000. Okay. Then 1 plus 14 over 100. We are having what is the power there? We are having the power of 2. We are looking at 649,800. So it's 649,800. Okay. Now this is our amount that we have here. Now during the next 3 years, he managed to secure an average compound interest rate of 12% per annum. What was his investment then worth at the end of the next 3 years? So now remember here, we are now dealing this thing here, he reinvested the amount. So we are dealing now with this one as our principal now. So our P now for number 2, this is number 1. Our P now should be equal to 649,800. Then our I should change also to 12 over 100. Then our N should be equals to 3. Then we substitute that. It's going to be 649,800. Okay, in bracket 1 plus what is our percentage there? Our percentage should be equals to 12 over 100. to the power of 3. Then we punch that in the calculator. So we're going to say here times, that's our answer. We put the bracket 1 plus 12,000, 12, sorry, amen. 12 over 100, okay, over 100 to the power of 3. So here we are having a power of 3. Then let's see what we get. We are getting 912,922. So here 912, 922. So here we are going to round it off to the nearest whole number. Okay. Now, so here is the thing here. So what happens now, it's more like here, what we are having here, we are having a timeline like that, but we're not going to be talking about this for now. So it's more like this was invested over 5 years, okay? Because the first 2 years here, we are told that in the first 2 years, we are told that it's, what is it? It's 14%. Then here is now 12%. And at this point here, it's 649,800. Okay, that's what we are dealing with there. So here, just for you to remember there. Okay, let's move on to the next question. We are calculating P now. So in our equation here, for the first one, 7 years ago, we are told number of years, a certain amount of money was invested in a bank. So we don't know what was invested in the bank. The value of the investment is currently 350,000. So that's accumulated amount. That's it's accumulated to 350,000. Calculate the original amount invested, which is our P, if the interest rate was. So here for the first one, we are going to deal with what? We are dealing with the simple interest. So simple interest is A is equals to P1 plus IN. So here, what I encourage you to do here, from the set here, we have got P. We can make P subject to the formula. So what we need to do here, we divide both sides by 1 plus IN. 1 plus IN. So here, that's what we have. So we're going to say P is going to be equals to our A over 1 plus IN. So here, what is our A? So we've got A is 350,000. Then we have got I, which is 3.25%. So in this case, let's put it over 100 so that we know that we're going to punch as it is. Okay. Now, what is our N? Our N is 7. So we're going to say, in this case, we're going to say 350,000 over 1 plus, what is our I? 3.25 over 100 times 7. So let's just extend that. So here we can come and punch our calculator. It's 350,000 over 1 plus 3.25 over 100 times 7, because the N is 7. What do we get? We are getting 285,132.38. So 285,132 is 285,132.38. Okay, so here is our amount. That's what was invested. So if you had to round it off, we can get what is it? 285,132 as it is like that. Okay. Now, then what about the next one here, where we are saying is 3.25 on the compound interest? Again, here we are not going to do it differently. Remember, our formula is A is equals to P in bracket 1 plus I to the power of N. So here what we are having now is that we are going to divide both sides again by the same amount. So by the same same what you call 1 plus I to the power of n over 1 plus I to the power of n. Now our P now then becomes A over 1 plus I to the power of n. Or we can say A 1 plus I to the power negative n. So you can see this formula, then don't get confused here, because it's more like 1 over A is equals to A to the power negative 1. So going back, let's say to the power of n is A to the power negative 1. So that's what we're having here, because we are putting it as a denominator. Okay, we are putting it as a denominator. So let's not forget that. So here, so you can use this one whichever way you want, but I'm just going to circulate this so that you remember what it means. Okay, and then now let's now put our values here. Having 350,000 over 1 plus, what is our I? 3,25, it didn't change, over 100 to the power of, what is our power there? What is our n? Is 7. Then let's see what we get there. So it's 350,000 over 1 plus 3,25 over 100. Okay, then what do we get there? To the power of 7. So that's what we get there. We get 279,000. So 279,793. 279,793. 279,793. 50. So here, if you are round off to the nearest whole number, it should be equals to 279,794. So this is the amount that was invested. Okay, that was the amount that was invested, and you can see that there isn't huge difference with these numbers. Okay, these two numbers. So that's also a guide when you're doing what called your sums. Now let's look at E. What amount must be invested now in order to receive 650,000 in 5 years' time if the compound interest rate is 6% per annum? So here, what you're dealing with here is the same as number 2. So here you are just solving it as number 2, because we are using compound formula, and you're going to use what? You're going to use this formula here. Okay. Now let's see when we're calculating also n. When we're supposed to calculate n, which is number of years in this case. So now let's look at it and see how we are supposed to calculate n. Now, how long will it take for investment of 50,000 to increase to 65,000 if the interest rate is 5.5 per annum simple interest? Now here, remember, it's simple interest, so we're going to use our formula. A is equals to P 1 plus IN. So now we are looking for the n. So first thing first, you always have to divide with P to remove P on this side. Okay. So first thing first, you must divide by what? By P both sides. That's what you're supposed to do here. So here, I'm just going to do it with P when P is still there, so that you have got 1 plus IN is equal to A over P. So here, let's see what we're having now. 1 plus I, which is our what? Which is our I is 5.5 over 100 times n, which is equal to, what is our initial accumulated amount is 65,000 over 50,000. Then what are we having here? We're going to get our value there. Now let's see what we are getting here. If we are to say 65,000 divided by 50,000, what do we get? We get 1,3. So 1,3. And here, what are we having? We're having 1 So we can take our 1 that side. We can take our 1 that side and take this side. So it's going to be 5,5 n over 100 is equals to 1,3 minus 1. So here we're taking the 1 that side. So it's going to be 0,3. So then we are having 5,5 here. N over 100. Now let's try to multiply both sides by 100 to remove 100. So we're going to cross multiply here by 100. Then we're going to left with 5,5 is equal to 0,3 times 100. So we're just going to shift there 0,3 times 100. So you move your what is it, your comma there, 2 units, 2 commas to the right. Now here, what are we having? We're going to divide by, so here, sorry, we're going to divide by 5,5 here. 5,5. So our n should be equals to 30 divided by 5,5. What do we get there? We get 5, so it means that is 5, 0, sorry, 5,4,5,4,5. It goes on like that, okay? Now, so if it's the 5 is representing 5 years, okay? 5 is representing 5 years. Now we want to get the months. How many months now? So what you must know here is that if we've got 5 in full, we are left with 0,454545 goes on like that. So here we're going to be saying 5 years. Then we are going to have 0,4545 goes on like that times 12, so that we understand how many months are there, okay? So here we can just say minus 5, then we get that, which is going to multiply by 12. Then we get 5 is going to be 5 years, 5 months. So our answer there should be equals to 5 years, 5 months. Because if you multiply here, you're going to get 5, so 0,4545 years well. So it's going to continue like that. So it's going to be 5 years, what is it? 5 months, okay? So I just want to put the nice 5 there so that you look it nicely. Now, let's look at the other one here that we're having. Calculate how long it will take for investment of 9,000 to double if the simple interest rate is 11,5. So we're going to use again our A is equal to P1 plus IN. But now let's see here. We are told that how many years will it take for this amount to double? So for this amount to double, now it means that our A should be equals to 9,000 times 2. So it's doubling, so it's going to be 18,000. So it's going to be 18,000. So here, that's what you must understand here. So when you're saying how many years will it take to what you call for it to double? So in other words, we can put it as A is equals to 2P. Okay. So here, yeah, it goes to 2P because we're multiplying the principal amount times 2. Okay. Now, so let's look at it and see what we're going to get there. So remember what we have agreed. We are saying 1 plus IN. Remember, we are dividing both sides by P. We are dividing both sides by P. So it's going to be, let me just put it in this way. Let me try to solve it with the values here. So we are saying accumulated is 18,000 is equals to 9,000. Then 1 plus our I is equal to 11 over 100 times, what is our N? Our N, how long will it take? So we're looking for N. Now here, what are we going to do in this case? We're going to divide both sides by 9,000. So it's going to be 9,000 by 9,000. So here we cancel, here we're going to get 2. We'll get 1 there. 2 will be equals to 1 plus 11n over 100. Okay. Now, what do we do here? We're going to get 2 minus 1. We're going to get 1 there. We take the 1 that side. So 1 goes there. Then 2 minus 1 is going to give us 1 is equals to 11n over 100. Then we cross multiply by 100. 100 is going to be equals to 11n. So we are cross multiplying here by 100 to remove the denominator. So we are multiplying by 100 here. We also multiply by 100 this side. Okay. Now, then let's we see what we're going to get there. We're going to divide 11 and also this side 11. We cancel there. N should be equals to, let's see what we get there. If we say 100 divided by 11, we must get 9,0909. So it goes on like that. So it's going to be 9,0909. So here what we are going to have now is going to be 9 years. So that one is 9 years. But now I want to see how many months now. So how many months is going to be 0,0909 times 12. So we just put in our calculator there. We're going to say minus 9 so that we can get that decimal. Okay. Then we multiply by 12. Then we see that what we get here is 1,09. So it's going to be 9 years, 1 month. Okay. So that's what we're going to have there. 9 years, 1 month. Okay. Now let's move on to the next one. Now we are now calculating I, which is our interest, which is now the interest. Now let's have the question here. Paul invested 5,000 and it accumulates to 55,000 over a period of 5 years. So here we are having our A. We're having our A. Our A is what? Our A is 35, is 55,000. Then our P should be equals to 35,000. Then our, what is our N? Our N is 5. And what we are looking is I, which we don't have. So now we're going to look at the first one. It's saying what simple interest rate would you need to secure what we call the 55,000. So what we're going to do is going to have our formula. A is equals to P1 plus IN. Now, with 1 plus IN, what are we going to be looking at now? We are going to find I. So again, we must divide that side. So we're going to put our values, 55,000 is equals to 35,000. 35,000 in bracket 1 plus I, we don't have. What is our N? So it's going to be 5I. Okay. Now we divide both sides by 35,000. We divide both sides by 35,000. Okay, there we cancel. So here it's going to be 55,000. 55 divided by 35,000. What do we get? We get 11 over 7, which is going to be, let's just put it as a fraction. Okay. 11 over 7 is equals to 1 plus 5I. Now we can take the 1 that side, 11 over 7 minus 1 is going to give us 5I. Now what is the 11 over 7 minus 1? What do we get? We get 4 over 7. So 4 over 7 is equals to 5I. It's easy to work with fractions in this case. Use fractions that will to make your life easy. Okay. Now let's now divide by 5 both sides. So we're going to say here we divide by 5. We want to be left with what? What is it? You can put this one in bracket now. We want to be left with I only here. So I will be equals to 4 over 7 divided by by 5. So we get 4 over 35. So it's 4 over 35. Now our interest, now remember our interest rate is 4 over 35. And if you are to put it here, what are we going to have? We're going to have 11 comma is going to be 0 comma multiplied by 100. Don't forget here, we're going to have 0 comma 0,11429. So 429 goes on like that. So what we're going to have here, we're going to multiply it by 100. So we have a normal percent there is going to be 11,43%. Okay, that's what we get there. 11,43%. That's our percentage. Okay, now let's look at the second one, which is number 2. This was number 1. Now, what compound interest rate would you need to secure? Now you are looking for the compound interest. So we're going to use the formula A is equals to P1 plus I to the power of n. But now in this case, now we are looking, we have got the n, we have everything that we need here, but we only don't have I. So what we're going to do here, we're going to write it again. 55,000, remember, over 35,000 is equals to, no. Okay, is equals to 35,000 in bracket 1 plus I that we are looking for to the power of how many years? 5. Now we're going to divide both sides here. 55,000 divided by 35,000 is equals to 1 plus I to the power of 5. Now here what we get here is 11 over 7. Remember, 11 over 7, we did it this side. So it's going to be 1 plus our I to the power of 5. Now we want to remove 5. What do we do here? Remember, if ever you have a question that you are saying maybe is x is equals to x squared, maybe is equals to 4. For you to get rid of the 4, you must root. So you are going to say root both sides. It's going to be root what? 4. But now we just used to this one. What about if it is x to the power 5? Like in this case here, what do we do now? Is equals to maybe 8. What do we need to do here in this case? We are going to root again, but we can just say root. But what we're having here, we are going to have x is equals to root, but now we put the 5 here on the root. So it's going to be what? It's going to be over 8. That's how you get your x. So here again, the same thing. We're going to do the same. So it's going to be a 5th root of 11 over 7 is equals to 1 plus our I. So we go on to our calculator and say and punch it as we see it to say what is it? We use this one here. We shift. Then we put the 5 there. Then we go inside there. We put 11 over 7. So 11 over 7. Then what do we get there? We get 1,09, and which you can't get as a fraction. So it's 1,0946. It's 1,0946. We can continue like that. 0.87 is equals to 1 plus our I. Then we take the 1 that side is going to be we're going to subtract that. So we're going to say minus 1. Then what do we get there? Because if 1 goes that side, it's going to be minus. So you're going to have 0,9094687. That is our I. Then we multiply it by 100. So if you multiply it by 100, what do we get there? It's going to be 9,46%. That's our I. So our I is 9,46%. So we multiply here by 100. then we get 9.46%. Now, so I don't know if you have any question here. So on our values, you must always leave them to 2 decimal places. Our answers, you must leave them to 2 decimal places. Let's just try to check here if everything is correct here. You understand everything. We must suppose to leave our answer to decimal places. So for this case here, what we'll need you to leave the answer is you leave it as 2 decimal places. Then here should be 50. You must leave it 2 decimal places like that. Then here we also need to leave it 2 decimal places, which was comma 20, if I remember very well. Just want to correct here. It was 649,800 in bracket 1 plus 12 over 100. Okay, so it was 21. Okay, so it's gonna be comma. I'm putting this one with the red so that you know that your answer, you must leave it in 2 decimal places. Okay, so here again I'm gonna put it in a comma 20 there. This one is fine. Then this one is also fine. Okay, so that's what you must always remember, that your answer should be left in 2 decimal with the 2 decimal places, unless specified that leave it as a whole number. Okay. All right. Okay. Until next time, guys. Thank you so much. Bye-bye. Let's meet on exercise 2, our next lecture.